This problem from the book is number 31 on page 300. And we're going to use a coterminal angle to find the cosine of 8 pi over 3. So let's remember that 8 pi over 3 is not on your unit circle. Let's find an angle that is. And we're going to do that by repeatedly subtracting 2 pi. That make sense? Okay. So let's start with 8 pi over 3 and subtract 2 pi. Now 2 pi is not a fraction, or is it?
Yes, over 1.
Right, it's 2 pi over 1. Now to subtract these we need a common denominator. What's the common denominator? 3. So can I write times 3 over 3? That'll give us 8 pi over 3 here. And this will be what pi over 3? 6 pi over 3. Right? So what is that equal to? What's 8 pi over 3 minus 6 pi over 3? Well, we know that the denominator is going to be 3. What's the numerator? 2 pi over 3. Okay. Is that on our unit circle?
Yeah.
Very good. Is it okay if I don't? I'm going to show it on the screen anyways. So on your unit circle, and we wanted the cosine, right? So here's 2 pi over 3. I had it right the first time. Here's 2 pi over 3 on the unit circle. See if it focuses. And so the question is, I'm going to zoom in a little bit. We wanted the cosine. Which value is that, the x or the y? The x value. I don't know if you can see that yet, but I'll try to zoom in a little bit. It won't zoom when I have to record, I guess. Didn't know that. So if you can see this on your paper, here's 2 pi over 3. The cosine is this value. I'm pointing up there, and I should have been pointing here. I know it's kind of blurry here, but the cosine is this. So what's the cosine? Negative 1/2. And so let me write what I just said. We want the cosine of 2 pi. We only had to do this once, didn't we? 2 pi times 1 plus 2 pi over 3. And what can we get rid of here? This is times 1. We can get rid of the 2 pi times 1, can't we? This is the cosine of 2 pi over 3, which you guys said from the sheet, which I just shown, that that's equal to negative 1/2.
Why can't we get rid of the 2 pi?
Good question. Why can we get rid of it? And the answer is because of what it says in your notes. I'm going to write it on the screen here because it's kind of small. But I want you to look on page 298. On 298, that's a good question. The question was, why can we get rid of the 2 pi times 1? Right? Here's the reason. Here's what your notes, your book says. Your book says this. If you have, let me see if I can find another color here. Well, I don't need another color. If you have the sine of 2 pi, they put it in a different order. They put the 2 pi times any integer plus any angle, which they call t. It's equal to the sine, the same is true for cosine, okay, of that angle, t. It says that these are the same. Do you see where it says that in your notes? Right on top of the box where it says definition of a periodic function. See what I'm saying? It also says the same thing for cosine. So the cosine, I know these two are switched around in order, but that's the same. Is it 2 pi times n plus t, the same as t plus 2 pi times n? Okay. So I'm going to still write it this way. 2 pi times an integer plus t. I don't want.
No matter what integer it is.
Correct.
Even if it's a fraction.
No. An integer, a fraction is not an integer.
Oh, yeah.
Right. You said it doesn't matter what integer. Right. It does matter if it's not an integer. But it could be 100, could be 7, it could be negative 2, which we're going to see in a minute. And that's equal to the cosine of t. So your question was, why? First of all, not just because the book says so, but because these angles are coterminal. Remember what that means? It means they just went around another time, or 2 times, or 3 times. And when they went around once, how much did they add? 2 pi. If we went around twice, they added 2 pi, no, 2 pi times 2, 4 pi. 2 pi times 2. If they went around 3 times, it would be 2 pi times 3, 6 pi. But we would write it as 2 pi times 3. So it could be 2 pi times 3, times 4, times 5. That just tells how many times they went around. And it doesn't matter how many times they went around, it still stops at the same place. And what do we call angles that stop at the same place? Coterminal. And the reason we study coterminal angles is because they have the same sines and cosines of the angles that are on our unit circle.
Or are they times when we don't have an integer and we have a...
Yeah, but I'm not going to give you any of this. I'm not going to ask you to do that. All right, I'm going to stop recording now.
Well, not yet. Or are you?